Software testing has variable meanings. The term has evolved as new software development lifecycle (SDLC) models have been introduced. Regardless of the changes to the exact definition, software testing is an activity or set of activities that are conducted to evaluate software to determine the following: have the requirements been met? Is the software fit for purpose? Has the risk been reduced enough? Have important defects been identified and addressed? Each of these questions tends to elicit more questions. Software requirements come in many forms, including formal requirements documents prepared by business analysts, BAs, technical requirements documents such as functional specifications, design documents, and interface design documents, higher level documents such as use cases which describe how an expected user would accomplish tasks or goals by using the software, SDLC unique documents, such as user stories in the Agile Lifecycle model, very informal diagrams on whiteboards and results from workshops, word of mouth, and drawings in a highly collaborative environment where the team is all working together all the time. The ability to verify that the software meets the requirements is dependent on the clarity of the requirements. If a requirement is clear and defines exactly what the software is supposed to do, the verification is straightforward. Where the requirements are vague or missing, the tester must be able to apply their own knowledge of the users and domain in order to determine if the requirements have been met. All software is designed to fulfill a purpose, but just accomplishing a task is not enough. In order for it to be fit for purpose, the software must work for the people who will be using it, in the environment in which they will be using it. Because there is rarely enough time to perform all the testing possible, risk prioritization is used to limit the testing to what is needed to mitigate risk to an acceptable level. Determining what is acceptable may be a matter of opinion, which is why risk analysis requires cross-functional input to ensure each risk is being considered and rated accurately. One of the purposes of testing is to find and fix defects before the software is released to the users. Defects, also called bugs, are flaws in the software that cause it to function incorrectly or cause the user to use it incorrectly. Clear requirements help in determining what is a defect and what is not. The less clear the requirements, the more discussion will be needed to determine if an anomaly is actually a defect or if it is just an undocumented feature of the software. Keeping the user's view in mind when testing the software helps the tester to better determine what a user would consider to be a defect. For example, an incorrect text prompt "enter sewer name" is clearly a defect. What if the username always has to be between 515 characters but the user is not told that? Is that a defect? As you can see, questions lead to more questions. Defect identification and proper recording is an important task for a tester. Defects that are not recorded accurately are difficult, if not impossible, to fix. The role of a tester can vary with different organizations and different lifecycle models. While software testing is a profession, others may periodically carry the title of a software tester. For example, in an agile lifecycle model, everyone on the team has testing responsibilities and may be considered to be a tester. For example, business users may become testers during UAT. Software developers are testers when they are testing their own or another developer's code. Regardless of the name of the role, testers are responsible for gathering information that can be used to assess the quality of the software. This information includes tests that have been run and have met their goals, passed, tests that have not met their goals, failed, defects found, risks mitigated, test coverage in terms of tests executed versus not executed, code covered versus not covered, risks mitigated versus not mitigated, or requirements tested versus not tested, and other information needed by the stakeholders. All testers need to be familiar with the essential areas of software testing. Specialization in these areas may require further study, but a general familiarity is necessary to understand what can and should be tested for any software product. Thanks for this lesson. Hope to see you in the next one.